Example 1. Suppose that a marketing research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they own cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones. Okay, step 1, we're going to verify our conditions, making sure there are really no red flags, particularly on that third condition. So was this a simple random sample? Yes, it says that 500 adults were randomly selected. We have to assume it's a simple random sample. 2, is 500 less than 10% of the total population? Yes, it says it was sampled from a large city. And number 3, the large count condition, and it's good, particularly in the AP, that you show this, that you say these conditions are met, and that you show this calculation. And if you're not taking the AP, it's still good that you show this on your page. So recall, to meet this large count condition, let's look at our sample proportion. 421 over 500 was 0.842. We plug 0.842 in and the n, and both of these check out. Both of these, 500 times 0.842 is bigger than 10, and 500 times 1 minus 0.842 is bigger than 10. So now that these conditions are satisfied, we can use our confidence interval formula with z star equal to 1.96. This corresponds, recall, to the 95% confidence interval. And substituting these values in, we're going to get 0.842 plus or minus 1.96 times the square root of 0.842 times 1 minus 0.842 all over 500. Be careful when evaluating this. I would evaluate this in pieces. So I'm going to evaluate this, what's under the square root. And I'm going to hold off on rounding too much. I'll take it out 2-3 places past what we have in the original problem. So I'm going to get 0.842 plus or minus 1.96 times 0.016312. Again, that's our standard error. Sometimes that's all we want is the standard error. Multiplying the critical value times standard error gives us the margin of error of 0.0320. So when we say 0.842 plus 0.0320 and 0.842 minus 0.0320, we can now interpret our interval. And there are a couple of different ways we can interpret this. So we're 95% confident that the true proportion of adults in the city who own cell phones is between 81% and 87.4%. Or we can say we're 95% confident that between 81% and 87.4% of adult residents of the city have cell phones. A little more naturally sounding way to interpret it. I think that second one is. Suppose that someone claimed that over 90% of adults in that city have a smartphone. So based on your confidence interval obtained in Part A, so let's comment on this claim. So pause the video here if you haven't done that and see if you can think about that. Okay, welcome back. So let's note that our 95% confident interval, the 81 to 87.4%, it gives an interval of plausible values, right? So it does not contain the 90%. So this actually would cast doubt on this person's claim. Later on, you will learn how to use a statistical test to determine this as well. So this is one angle to look at it, using confidence intervals to test claims. Let's do the same problem using technology, which is how most of you are going to do this. But it's good that you can do a few of these by hand. You'll really be able to see where these values come from and not just have this sort of magic black box that you've got with your calculator. Let's start with the TI-84. So step 1, press Stat, scroll to Tests, and select A, 1 prop Z interval. So this is one proportion, and we're looking at Z interval. Step 2, we're going to put in our X and our N, and then we select the confidence interval and select Calculate. So we're going to see the interval displayed, and it also gives you the p hat and the n. I like that in case I didn't put it in right, or sometimes they don't actually give you X and N. They may give you a percent, and you actually have to take that. So it's nice that you can see what p hat is. Now, what if all of the choices on a test or on the AP test are in the plus minus format? So we need to determine the margin of error, or maybe they just ask what's the margin of error. The calculator input doesn't give us the margin of error. It gives us the interval. Well, we can figure this out, right? We just do the upper minus lower divided by 2. That's going to give us the margin of error, 0.0320. Same thing we obtained when we did this by hand, right? So we did p hat plus or minus margin of error, 0.842 plus or minus 0.320. So recall this is the same as we obtained by hand. So in using StatCrunch, step 1 in StatCrunch, go to Stat, proportion stats, one sample with summary. Step 2, you're going to enter the values in, number of successes, this is our x, over the number of observations, that's our n, and select confidence interval. And we're just going to use the standard walled method, 0.95. And press compute. Notice we get exactly the same interval we have obtained both by hand and on the TI. So we give lower limit and upper limit, so again 81%, 87.4%.